Chapter 10, we're going to be focusing on data, or you can call it data. It can be pronounced either way. This is very important to understand because while you may not be doing a whole lot of gathering data or displaying data in the way that we're going to learn in these lessons, you are going to be shown a lot of it throughout your life, especially with the internet, which I know that's all the life you've known is internet, but I remember when. Before that time. Anyway, the point is we get shoved a lot of data, and being able to read it and understand it is very important so you know if what's being described about that data is true or not. So when numbers are collected from a group of people or objects, the job of a statistician is to measure and interpret the numbers in such a way it's helpful for people so you can understand that data. Finding a single number that helps represent the whole group of numbers is often the first thing they find. That number is called a measure of center. And you may not have heard the phrase measure of center before, but I think as you'll see, you have learned types of them before. So measures of center, the first one is the mean. We also call this the average, but it's the sum of the data divided by the number of items in the data set. There's also the median. If you would put the numbers in order from least to greatest, it'd be the number in the middle, or as we'll see in an example, if there's an even amount of numbers, there could be two numbers that are in the middle, then you take the mean of those two and call it the median. And last is the mode. It's the number or numbers that occur most often in the list. The purpose of these is to have a single number that gives us some information about the whole group of data. So let's do it here. So find the mean, median, and mode of the data in the table. So just so you know what this is representing, as you hopefully know, the U.S. government is split into three main parts. The executive branch, the president is the lead of that part. The judicial branch, the Supreme Court is the lead in that part. And then the, I just lost the name of the third one. Judicial, executive, legislative, there we go. And that is made up of the two houses, the House of Representatives and the Senate. Every state gets two senators. But the House of Representatives, it depends on the population of your state, how many representatives you get. So this is the number of representatives for these states. It may have been adjusted since I got this data, but this was correct at some point in the recent past. So California, being the most populous state, does have the most representatives in the House. New York's very populous, but you can see it's not nearly as populous as California. New York City is huge, but as a state, California has a lot more people. You can see Florida has a pretty big number, but smaller numbers down here. North Carolina has 13, and so on. So looking at these 10 states, we're going to find the mean, the median, and mode of these numbers. So for the mean, we need to add all of these numbers together. So this isn't difficult, but it does take some being careful that you do it correctly. So I just need to add up all 10 of these numbers. And in your calculator, I know you can't see the whole thing very easily. I can go up, which is cool. I thought I could. Oh, maybe I can't. I thought I could then go over and see it. Anyway, regardless, it doesn't hurt you to do it more than once just to make sure you typed it all in correctly. But the total is 236, and there's 10 states here, so I divide 236 by 10. So the mean number of representatives that these states get is 23.6. Now I'm going to write 236 over 10. And that would be a good habit for you to do also, to write the sum and divide by the number. Because for one thing, that displays the total and the number, but it also lets me know if you're on the right track, you've done the right thing. because you could get partial credit if I see, oh, you added these together wrong, but you did divide by the right number, so I know you knew what you were doing, you just made a mistake in the calculator. So the mean number of representatives in these 10 states is 23.6. Okay, so for the median, we need to list these from least to greatest. As I look, 13 is the smallest, and I need to list it twice because both New Jersey and North Carolina have that many. Next smallest would be 15 from Michigan, then 18 from Ohio. Then we have two 19s from Pennsylvania and Illinois. And again, if it shows up twice, you list it twice here. Next would be 25 from Florida, 29 from New York, 32 from Texas, and 53 from California. I'll just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. With a smaller list of numbers, you might be able to just look and tell what the middle number is. But with a longer list, one thing you can do is just cross off the ends. What I mean is I'll first cross off the 13 and the 53. Now that's just step one, but you got to do it on both sides. 13 and 32. 15 and 29. 18 and 25. So this is an example I talked about where you might have an even number in the middle. You have 2 in the middle. Now these are the same. So that makes it pretty easy. The average of 19 and 19, or the mean of 19 and 19, is 19. But just to make sure it's clear, let's just pretend for a second these two numbers are like 24 and 20. We'd add those together and divide by 2, and then that would be our 22 would be our median. So if there's two numbers in the middle, add them together, divide by 2, and that's your median. Okay, the mode is the number or numbers that occur most often. So I see two 13s and two 19s. So we actually have two modes. And the question that's probably going to be asked is, well, what if no numbers repeat? Then we usually just say there's not a mode, because if there's no repeats, every number appears the same amount of times, then there's not really a mode that helps us or informs us about anything. So our mean is 23.6, our median is 19, our mode is 13 and 19. So that's the measures of center. Now, a new concept on the back. Percentiles. If you've ever looked at your SAT scores, the SATs we take every year, these show your grades as percentiles. That's different than the grades I give you on quizzes and tests. I'll explain that in a minute. So percentiles, not percentages, but percentiles, tell us what percent of the data are below a certain value. Ooh, I should update this. This is a year off. But anyway, last year in my house, the ages of people living there were 39, 38, 13, 12, and 10. The 39-year-old, that was me, was in the 80th percentile because 80% of the people in the house have an age lower than him. So this is already listed in order. So if you think about it, the 39-year-old, there's 5 people total, and 4 out of the 5 0.8 or 80% are younger than the 39-year-old. So the age for this person puts them in the 80th percentile. 80% of the people in this house are younger than him. If I was looking at Mrs. Lynn, the 38-year-old at the time, 3 out of 5 or 60% were younger than her, so she'd be in the 60th percentile. Now on your your SAT scores, so if you see something like an 85, that doesn't mean you got 85% of the answers correct. Now it might mean that might be true, but that's not what that number means. It means that you scored higher than 85% of the people who took it. So it's saying where you rank in your scores compared to everybody else who took it. One other thing you may or may not have thought of here is with a percentile, you can't actually be 100%. Now, with a huge list of numbers, you could be like 99.99%, and they may just round it. But technically, you can't be the 100th percentile, because that would imply everyone is lower than you, but you're part of everyone, and your score can't be lower than yourself. Your score can't be lower than your score. I can't be younger than myself. So here's another example. A talent show was held for 20 finalists in the Teen Idol contest. Each performer received a score from 0 to 30, with 30 being the highest. Find Victor's percentile rank. Okay, so I'm walking through this step by step to try to help you see how to figure out the percentile. So we want to order them from least to greatest. Okay? So as I'm scanning through this, looks like 4 is the least, so I'll put 4 first. Oh wait, sorry. It's important to read directions. Here I am doing the video and nearly did this backwards. Order the scores from greatest to least. So I need to not do Pearl's score yet. Let's see. Okay, 28 appears to be the... Nope, wait. 29. 29 is the highest score. So let's just put a check there so we know we've covered that. Then is 28. Let's see, I see 26 here. And 27 over there, there we go. So 27, then 26. So I can put a check by these two names. Then there's a 25. For other 20s, there's a 21, 22, and a 20. Okay, so 22, 21, and 20. Okay, are there any 19s? No, there is an 18 though. So let's put that there. There's a 17 right there for Arnold. 16 for Kat. 15 for Fernando. Look, 14. Then 12 and 11. 10. 9, 6, 5, and don't forget Pearl, I already marked the 4. Okay, I know that takes some time, but the good part about data is it's usually not very difficult in the math sense of it, but it is challenging sometimes just to work with a large volume of numbers. But anyway, so we've ordered them from least to greatest. There are a total of 20 people here. That was told to us up here. You don't have to count. So we want to know, find the number of scores below Victor. So here's Victor. He was the 28. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So Victor scored higher than 18 of the people who were in this contest. Now, to figure out his percentile, we need to divide that number by the total number of scores. So 18 divided by 20, because there were 20 scores, we get 0.90. Then we multiply that by 100, and we get 90%. So Victor is in the 90th percentile of this contest. That means his score was higher than the scores of 90% of the people who were in it. So now we've already got them in order. So it says which people scored below the 30th percentile. So we want to figure out the 30th percentile. So let's do this. 30 over 100, because 30% is 30 out of 100. Remember, percent means per 100. And I know there's 20 people, so let's divide this by 5. So divide 30 by 5, divide 100 by 5. We get 6 over 20. So that means the person who is the 30th percentile is the person who has 6 scores below them. So again, this is important. You're in the 30th percentile if 6 people scored lower than you did. So we count 1, 2, 3, 4, 5, 6. But it's this score that's the 30th percentile, because that person scored higher than 6, 1, 2, 3, 4, 5, 6, scored higher than 6 out of the 20. So it's not the 6th person, it's the person right above that, because the percentile tells you how many people have data or score lower than you. So the people who scored below the 30th percentile, well, the person who scored 12 is the 30th percentile. So the people who scored 11, 10, 9, 6, 5, 4. So the bottom 6, which, let's see, 12, Heather. Oh, not 12, sorry, not 12. She's number 7. 11, so Ingrid. 10, Malik. Benito's 9. Let's see, we don't have an 8, so 6, 5, 4. So Twyla, Horatio, and Pearl. So these people scored below the 30th percentile, because Heather, who scored 12, was the 30th percentile. So everyone who scored lower than her is below the 30th percentile. Which people scored above the 80th percentile? So we'll follow a similar pattern here. 80th percentile, that means 80 out of 100. But we just had 20 people, so let's divide these by 5. 80 divided by 5 is 16. 100 divided by 5 is 20. So we need to find the 80th percentile first. So the 80th percentile is the person who has 16 scores below them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the person who scored 26th is the 80th percentile, because 16 out of the 20 scored below that person. So those who are above the 80th percentile are the top 3 scores. So the highest scores, let's see, the 27 was Ishi, 28 Victor, 29 Delia. So be careful with that, because this is one place people can get mixed up, because we have to find the 80th percentile first. That's the person whose score is higher than 80% of the others. Then we go above that, because it says above the 80th percentile. Okay, last concept is the 5-number summary. So if you remember, we talked about the measure of center on the first page. That's where you can have one number that gives you a decent idea of what's going on with the data. So now we're going to use 5 numbers to give a fuller picture of the data. And one reason having more information is helpful is because 2 very different data sets can have the same mean or the same median. So look at these lists right here. Let's just pretend these are people's ages. So you find 5 friends who are all aged between 27 and 33. If you were to add these together and divide by 5, their average age or mean age would be 30. Their median would also be 30, because that's the middle age. So that's 5 friends who are pretty close together. Now this is a much wider range. This might be like at a family gathering. We've got different generations together. So you got a 10-year-old, a 20-year-old, a 30-year-old, a 40-year-old, and a 50-year-old. If you add those together and divide by 5, you also get a mean of 30. And they're already in order, so you see the median is 30. So if we couldn't see these, and all we were told was mean 30, median 30. That does tell us something. It tells us where the middle of these ages are, but it doesn't give us any hint that, oh, well, these are really close together, or not so close together. So to help describe these sets more fully, the statisticians of old created the 5-number summary. So they do use the median as one of the 5 numbers. They use something called quartiles to divide the number set into quarters. Quarters, quartiles. And then the other 2 numbers are the max and the min. Now that's really helpful because if I had told you the median age is 30, the minimum age is 27, the maximum is 33, then you have a very clear picture that, oh, these people are close together in age. But if I told you the median was 30, the maximum age was 50, then it was 10, you're like, ooh, that's pretty far spread out. Okay, now the quartiles, I think it'll be easier to explain actually once I start showing them down here. So let's do the 5-number summary for this set. Okay, so we're going to mark off this one and this one, 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 and that allows us to find the middle or the median. So 41 is the median. Okay, so now let's cover up the median. The median is like a boundary. What's to the right of it is the upper half of the data. What's to the left of it is the lower half of the data. This is where the quartiles come in. So we cover up that number. I'm doing it on purpose. We cover up that number, and we look and we say, okay, if I look just at these 5 numbers, what is in the middle in order of these 5 numbers? Well, that'd be the 36. So that is the first quartile, which we just call Q1. So Q1 means the first quartile. Then we ignore the median and look at these 5 over here. 49 is in the middle. That's the third quartile, or Q3. The median is almost always just called the median, but it can also be called the second quartile, so it can be called Q2. Then the max and the min are very easy. 25 is the min, 54 is the max. Last one. The number of boxes of donuts Aaron sold for a fundraiser each day for the last 11 days were this list right here. Find the minimum, the lower quartile, the median, the upper quartile, and the maximum of the data set. Then, down here, we will interpret that 5-number summary. Okay, so let's try to put these in order. Smallest one I see, 14. Okay, then 16. Then I see 2 17s. Okay, no more teens. There's a 20 and a 21. A 22 and a 26. 28, 29, and 35. Okay. And just, the commas aren't required. I'm not sure why I bothered. They could just be spread out kind of like they were in this set. You can put commas, you just don't have to. So let's start by finding the median. Well, I'll tell you what, let's just go ahead and, max and min are pretty easy to identify. Then it takes some work to find the other 3. Okay, so 1, cross off. 2, cross off. 3, cross off. 4, 5. Okay, we have found the median. It is 21. So then we cover up that number, that 21, and we look over at this side. Okay, so there's 5 numbers over on the left. The middle one is 17, so that's the first quartile. Then we cover the median, look over the right. 28 is the middle number. That's the third quartile. So we have found the 5-number summary. So over the last, sorry for that typo, I should say 11 days. Over the last 11 days, Aaron sold a minimum of 14 boxes and a maximum of 35 boxes. He sold fewer than 17 boxes 25% of the time. That's what the first quartile tells you. 25% of the data is below that. That's why it's called a quartile, because it tells you what percent is below that. The median is the 50% mark, so he sold fewer than 21 50% of the time, and fewer than 28 75% of the time. So this is actually what is used most often by statisticians with the 5-number summary. The fact that this is the 25% mark, this is the 50% mark, and this is the 75% mark. You could call this the 0 and the 100, but that's our max and min ideas are already pretty clear in our head. So we have the first quarter, 25% or below that, the bottom 50% from the median or below the median, and you could either say the 75% are below the third quartile or 25% are above it. So last thing I want to say before I end this is just as far as when you're finding the quartiles, let's say in the median, I told you cover up the median and then look at the top half and bottom half. So I'm just going to pick random numbers, but I'll put them in order. So let's say it was your list of numbers. So as you cross them off, we find we have a median of 11.5 because you have to add these together and divide by 2. So you don't actually cover up one of the data points this time. This time the median actually cuts it in half, and the 11 and 12 are included. When there's just one number that's the median and it's part of the data, you don't use that to describe the upper or lower half. That's why I covered it up. But if the median is between two numbers in the data, you just draw a line and you look at this. This would be the third quartile. This would be the first quartile. So in this case, you don't ignore any of the numbers when you're looking at the quartiles.